Hey everyone, thank you for joining us for the next session of Ask the Expert Fabric Edition. My name is Anna. I'll be your producer for this session. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our experts to answer. Our session is being recorded. It will be available to view on demand right here on the Reactor channel. With that, I'd love to turn it over to our experts for today. Thank you all so much for joining.
Awesome. Thank you so much, Anna. Hello, everyone. Good morning, good afternoon, good evening from wherever you're joining us today. Thank you for joining us in this exciting session about graph capabilities in Microsoft Fabric. My name is Nandini Srinivasan. I'm a senior product marketing manager on the Microsoft Fabric team. I'll be your moderator today. We also have a number of product experts with us today. Let's kick off with some introductions. I'll hand it over to you, Iggy.
Hi, everyone. Nice to see you. My name is Iggy Amster. I am the group product manager, Fabric Graph.
Will?
Hi, everyone. I'm Will. I'm also product manager on the Fabric Graph team based in New York City. Nice to meet you all.
Justin?
Hi, I'm Justin Fine. I'm joining from Southern California, and I'm on the product side for Fabric Graph.
And Anaga?
Hi, everyone. I'm Anaga Dodubagi. I'm also a product manager on this team, and I'm based in San Francisco. Excited to be here.
So here's a little bit about the format for today. Before we get into questions, we wanted to start off with a brief introduction on what Graph in Microsoft Fabric really is. Graph is relatively a new offering. It was announced in public a couple of months ago last year. So we'll take the first 10 minutes to talk about what it is, who it's for, what are the use cases, why do you need it, just help you get a brief understanding of it. After that, we'll answer your questions live on screen. In the meantime, feel free to keep the chat flowing with your questions. We will take technical questions, high-level questions, conceptual questions. We're open to all kinds of questions and conceptual questions. Iggy, why don't you kick us off with a brief introduction on Graph?
Okay, sounds good. Thanks you, Nandini. So welcome, everyone. Today is really about relationships, not just data, and why they are so fundamental for the AI, and how Fabric Graph and Fabric IQ in general makes the connected data usable at an enterprise scale. We will frame a little bit about Fabric IQ because this is the bigger concept, and then zoom into like Fabric Graph. This is why we're here today. Share some customer signals, and of course, answer your questions. So we start with a kind of a 10 minutes brief. We all know, okay, the data powers AI, but I think the more interesting or more important part is that the context makes it intelligent. Without business meaning and relationships, even the best LLM model can reason completely wrong. So the real enterprise problem, what we're saying, is simple. It's the missing context. Let's dig a little bit deeper there. So we all know dashboards, right? Dashboard is like probably the main symbol of data-driven decisions, but dashboards can only show what happened. They don't really explain why. Think, for example, on an e-commerce return spike. The cause is spread across multiple data points like suppliers, fulfillments, variants, cohorts, and so on and so forth. The data exists, but it's not connected. And if it's not connected, it's very hard to understand why the spike is happening. So what if your data platform didn't just show data, but also surfaced it and surfaced the right context automatically? Luckily, this is exactly what Microsoft Fabric, and specifically Fabric IQ, is all about. It's unifying the business semantics across data, models, and systems, so insights and AI agents can ground it in a live, holistic view of the entire business, of your business. And Fabric IQ creates a shared semantic foundation. The same concepts, rules, relationships for people and AI. Less confusion, less rework, and hopefully fewer hallucinations, of course. And if you want to take a look at a nice visualization, this is like the sheet today on the left side. People and agent tables in isolations. Okay, and in the future, for us it's now, AI is grounded in a unified business context tied to actions. The key takeaway probably is that relationships must be treated as a first-class citizens. Relationship first wins the AI era. So Fabric IQ actually contains several items like semantic models, ontology, graphs, agents, and so on and so forth. Today, of course, we're going to focus on Fabric Graph, right? Fabric Graph is the execution engine of everything. It's the reason, it reasons over relationships at scale, traversals, paths, cascading impacts, etc. But a closely related capability or item is Fabric Ontology. It's worth mentioning. Ontology defines the meaning, right? The shared businesses, vocabulary, rules, constraints, etc. It gives the context. Together, the ontology and graph together form a strong implementation of the knowledge graph concept. It's defining the meaning and the execution relationships and enabling a real AI-driven data-powered decision transformation at an enterprise scale. So what is really Fabric Graph, right? So instead of walking through additional slides, we would like to show you an end-to-end demo that we've just recorded with the product. You will see Fabric Graph in action, from selecting the data and modeling the entities and the relationships, of course, the nodes and edges, to creating data agents that can reason over with the power of graph, and finally querying and exploring graph with the no-code editor, the GQL editor, exploring and see everything in action.
Welcome to Fabric Graph. Our first step in building a graph will be adding data sources from our OneLake. We choose our data and then verify that the tables are what we need to run our analysis. By looking at the table structure, this will allow us to properly identify elements for our label property graph. Once our data is identified, we move on to building our nodes and edges. We start with adding our customer node by selecting the customer table and clicking Add. When adding a node, we choose a label that best describes the element. In this case, it will be customer. The last step is selecting the ID. In this case, it is customer ID, which is a unique identifier for our customer table. We continue to build our graph by adding an in-store purchase node, an item node, an online purchase node, and a ticket node. For each, we add the labels and the IDs as indicated for the customer node. Now that we have our nodes, it's time to add our edges. We start with connecting customers with their in-store purchases, drawing the relationship and indicating the proper mapping table, followed by both the source and target node key. Like the node ID, these are unique and connect the two nodes. After we connect the customer with in-store purchases, we add relationships for online purchases, tickets created by customers, online purchased items, in-store purchased items, and items that have tickets created about them. When we are satisfied with our model, we can save it by clicking the top left Save icon. It is important to note that the model is flexible, allowing you to add additional data sources by repeating these steps and expanding the current model. This is one of the unique and extraordinary features of Fabric Graph. Additionally, we see a save and load operation being performed. It is important to call out that the loading of your data into Fabric Graph does not include a typical ETL process. Instead, it is mapping the data in your OneLake into this new graph structure. Now that our data is ready to go, we move on to natural language interaction via our data agent offering. This allows any user to query the newly formed graph through the agent using natural language. First, we ask what our top 3 items are that have the most tickets. This will allow the analyst to find problematic items quickly. After some analysis, our agent comes back with Smartwatch X, Noise-Canceling Headphones Pro, and Gaming Laptop 15. For our next question, we want to see a list of customers who purchased the Smartwatch X online. Our goal will be to identify customers who may have run into a known issue with batteries in a shipment that went out of a warehouse recently. While we wait for the results, we can take a look at the GQL generated from our question to verify or learn. Fabric Graph uses GQL throughout the product as it is the ISO standard for graph databases. Once the query finishes, we can see the results and reach out to these customers. After we send out our emails to these customers, we navigate back to the Fabric Graph UI so we can continue exploring and analyzing our data. The next area we want to explore is our low-code/no-code query builder. This allows the user to build a query on the canvas and add filters and formatting as needed. Here we will select the customer node, followed by the online purchase node. This is indicating we want to see customers who purchase something online, not unlike our query in the data agent. We want to take this further by adding an item node and a ticket node. This structure now gives us a more complex query that we can see visually. And to take it one step further, we add a filter on the item node where product name is Smartwatch X. After that is set, we want to create a filter on the ticket node where the product name is Smartwatch X as well. This allows us to see customers who have purchased this item and created a ticket on that item. Once the query parameters are set, we can select Run Query, which will send the query to our backend. Quickly, we see a diagrammatic representation of the result, the blue nodes representing customers and the pink nodes representing the tickets. The diagrammatic view is a powerful tool for data exploration, and on the right pane, we have flexibility on what we want displayed. By selecting the node, we can update the display property to toggle between different ways to represent the nodes on the canvas. Here, we change both the customer and the ticket. In addition to the diagrammatic view, Fabric Graph also has a card view which allows users to index and sort by different properties. Here we are checking to see who our customers are, so we can proactively reach out to see if we can help with their experience since they purchased a problematic product and have submitted a ticket indicating that. Utilizing our GQL code editor is the best way to make use of our implementation of GQL to ask complex and difficult questions. One unique feature of Fabric Graph is that when you are building in the low-code, no-code editor, you can toggle to the GQL editor and see the generated code. Here, we want to identify customers who have purchased one of the top 3 most problematic items. Additionally, we want to proactively reach out to customers who have not yet submitted a ticket for those items. We utilize some complex GQL features in order to get our result. This is a great start to our ask, but we should probably prioritize this list some way. By adding a total amount spent and ordering the list, it will give us a great way to proactively reach out to our high-value customers. Over the course of this exercise, we have had the opportunity to identify data we want to connect in a graph structure, instantiate a data agent to ask natural language questions, use the low-code, no-code builder, and use the GQL editor for our most difficult questions, truly showing the power of Fabric Graph for any type of user with any depth of technical background.
Value propositions. First, it is built for all personas. As you could see, business users can explore the relationships visually or with natural language, while analysts, engineers can use the GQL, of course, for precision. Secondly, it's AI ready by design. Graph makes the relationships and the context explicit, which is how AI kind of reasons the best, and the play with the data agent is amazing, and we see great results there. Third, it's a native to Fabric, right? Running directly on OneLake with one security and governance model, everything with no ETL whatsoever. And the fourth, the last but not least, it's proven at scale. It's built on one of the most performant and large graphs on Earth, which is LinkedIn's ones. So it's pretty much influenced from its design and architecture, and makes it real. So together, this makes Fabric Graph practical for real enterprise use cases and AI workloads. And just before we move to the questions, we also want to show you that it's a quick proof point, right? Public preview, we've been running it for the last 6 months or so, and it's already providing very strong adoption. More than 800 customers or tenants playing with more than 5,000 active graphs, more than 70,000 queries per week. So really large numbers, and this is only in the public preview. But the real signals is actually what customers are saying, and it's across the board. Many industries, we have customers from almost every industry that we could think of, and it really, everybody is saying that they really get it, like the impact paths decision, not just the reports. So with that, I think we're ready for the main course, which is the questions and answers. So going back to you, Nandini, hopefully we have already some questions that we can start answering.
Yeah, no, that's awesome. I think what a powerful demo. What really stuck out to me was, when you said relationships are stored as a first-class citizen, right? That's what helps graph tend to reveal patterns that are hard to discover in, say, a relational database. So no, it's awesome to was that? Sorry. Yes, it's awesome to get that sort of overview on graph. And what's amazing about our chat right now is we have people coming in from all over the world. It's truly a global audience here. We have UK, Myanmar, East Anglia, Great Plains, South Carolina. So it's amazing to see such a global audience over here. I'm curious from the audience, where are you in your journey with graph? Are you kind of new? You're just still discovering it? Are you proficient? Are you very well versed? Or somewhere in between? Put it in the chat. We'd love to know where you are on your journey with graph capabilities. And in the meantime, I'd love to start off with just taking a step back. Maybe a question for you, Justin. It's so powerful to learn about graphs for the first time, right? So if somebody is used to maybe the relational databases, that sort of world, what are the top differentiation, or why should they think about graph if they're learning about it for the first time?
Absolutely. Well, Iggy mentioned this in his opening, and I'll start with hello everyone again. It's a relationship first sort of way to view your data, which is different and new. Some people are used to it and some people are not. So this, I think, creating your models with the idea that you're going to traverse over the relationships, you're going to connect data in a way that you might not have before. That's something that's very unique. When you connect that data, you have this capability that kind of pops up as well of multi-hop queries, right? And those become not only just kind of an interesting thing to do, but also the norm. So I can connect my data, seemingly disparate data that's sitting in different stores, and traverse over it, ask complicated questions, and get those answers back quickly. This becomes more and more important, as Iggy indicated as well, when we're talking about AI, connecting those models and building some things like knowledge graphs, asking more complicated questions like paths and things along those lines. One of the things that I love to talk about as well is the schema flexibility. So, we showed, building this model initially with, some things in mind. We want to ask questions specifically against the tickets and problematic items. But if we keep adding to that, we build on maybe the customer story. We want to do a customer 360. We want to keep building in that direction. We can add in more data. We can connect it very easily and hit save. And that's something that's unique, not having an ETL in that respect. Which is big when you talk about asking more difficult and complicated questions. I think those are the big ones. I mean, I have one more that I love talking about. I think I'll jump on that is the way that it's displayed. So it's the consumption of the answers is very visual and in the diagrammatic view, very helpful when you get to that stage, being able to consume what you've done as far as either the low code, no code editor or the GQL editor.
That is my favorite part as well. I just love that visual element of it, be able to look at all the different relationships and, identify those hidden patterns. So, Iggy, I think one of the things you talked about was how this really can empower organizations to adopt AI, right? So when you think about modern data architectures or that modern AI tech stack, how does Graph complement that? Maybe, Will, if you can take this one. How does Graph complement some of those modern AI tech stacks?
Sure. So when it comes to some typical approaches of companies implementing AI tech stacks, they typically leverage a lot of these neural network-based large language models or similar models. And a lot of these tech stacks also commonly involve vector search type of approaches to retrieve information that might be proprietary to enterprises. These tech stacks are generally very capable at summarizing information or presenting overviews. But the key is that the information has to be available within the context window for the large language models. And the vector search approaches are very good for retrieving relevant information that are similar, semantically similar to what is being put in the context window. But when it comes to large enterprises, you have this issue where you have a lot of disparate data that might have no similarity but are interconnected, and you would need to be able to pull all that interconnected, disparate data in, which is very challenging if you want to fit everything into the context window. And this is where a graph can really shine by allowing for that grounded retrieval of interconnected information. And I'm repeating myself here. By retrieving all that information across the whole enterprise, finding the relevance between data points that are not going to be surfaced using vector similarity-based retrievals, and data sets that are too large to fit entirely into the context window. And now you'll be able to perform this sophisticated reasoning across enterprise-sized knowledge graphs while enabling your LLM-based tech stacks to perform in-depth and complex analysis across your whole enterprise operations.
Awesome. No, that absolutely makes sense. I've been at Microsoft for about 9+ years now. I've heard of Microsoft Graph a lot. Iggy, maybe a question to you. What is really that difference between Graph and Fabric versus Microsoft Graph, which we all heard about in our day-to-day?
Yeah, it's a good question that we're asking. We've been asked a lot, and the answer is pretty short, that there is no connection between the two, but I'll explain. As you could see, Fabric Graph is like a solution, as a graph solution that Microsoft offers. You take your data, you model your data, and then you use the graph analytics features that we are providing to reason over the data and everything that you just seen. And the Microsoft Graph, right, is basically, you can think about it as a huge database. Okay, it can be modeled as a graph or not, doesn't really matter, right? But it's all of your work IQ, as we call it now, like emails, messages, documents, etc. Everything that Microsoft holds that is arranged for you to get access for via APIs, etc. So both have the word graph in it, okay, because it resembles something that captures data in a meaningful way. But again, Fabric Graph is a product, is a graph product for you to actually do whatever we just talking about. And the Microsoft Graph is the ability for you to access the M365 data of your organization.
Awesome. No, that's great to know. Sometimes we have the same name for something, but the use cases, the capabilities, and the way you use it is completely different. So it's a great point. We do have one question from Rich Parker, which was going to be my next follow-up. Yes, we get Graph in Fabric is different from Microsoft Graph, but can I not just use Graph features in, say, a database? If I'm using Azure SQL or Cosmos DB or even Azure Data Explorer. And Rich asked this question, what is that advantage of this graph, like Fabric Graph? Because maybe the same thing could be done with a gnarly deep SQL, is this something you can touch on, maybe Justin?
Absolutely. I love this question, Rich. This is great. So sometimes, yes, sometimes you can do some pretty amazing SQL and do the gymnastics. And if you're very good at it, I think that you can do some pretty amazing things. For graph scenarios, for the things that make a graph database really shine, is when you get to very large data and very large complex joins, right? So if I'm doing something like, 10, 15, 20, even that, you could probably do some pretty good SQL to get things done. But if we talk about, I have 10 billion rows of data and I want to join hundreds of times or thousands of times, then that becomes very difficult, especially if I don't know what I'm joining. So things like variable length paths, especially are very, very difficult in SQL. And the more complex you get with your regular expressions and your filtering mechanisms, that can be very difficult as well. So what we want to do is start off with this larger group and minimize it with our declarative GQL standard, right? So we can do a match statement there and kind of minimize it as we go down. But I think, in general, having those capabilities of bringing that data together and traversing over those relationships that don't have to be done on query are very, very helpful, right? Hopefully that helps. I'm absolutely excited to answer any follow-ups if you have any.
Yeah, no, absolutely. One other question I'm curious about is, when you think about Graph and Fabric, how does it integrate with OneLake? We talk about OneLake a lot with Fabric. Anaga, maybe you can take this one, but how does Graph and Fabric integrate with OneLake and maybe even the other Fabric workloads?
Sure. Fabric Graph is a native Fabric workload, so this operates directly on data that we have stored in OneLake. Graph models reference existing Fabric data, for example, the lakehouse tables, and exposes them as nodes and edges without having to copy this data into a separate graph database. And because this is native to Graph, the graph data can coexist with data engineering, warehousing, real-time intelligence, and Power BI, thereby sharing the same governance, identity, and workspace boundaries.
Awesome. I think that's really powerful, not having to do ETL, reverse ETL, move it out of the existing Fabric ecosystem. So that's an amazing answer. Thank you. I see one question in the chat from Puneet C2310. They'd like to know, how do we ensure that relationships model in Graph not only improve AI accuracy, but also remain explainable and ethically transparent in, say, healthcare or finance scenarios? I think that these are pretty important. So, Will, why don't you take this one?
Sure. I'm going to share a screen for this one. And admittedly, I hadn't prepared a slide deck for this. So what I'm going to be sharing is going to be, let me see if I can share a Word document on my screen. Okay, so the question here is, how do we ensure relationships modeled in the graph not only improve AI accuracy, but also remain explainable and ethically transparent? So I think what can be helpful is using a specific example here to talk about the advantages of using a graph to improve the AI accuracy and keeping it traceable. So let's say we have this hypothetical company that's called AdventureWorks, which is a multinational outdoor sports equipment retailer. They want to use the sales data that they have to be able to provide product recommendations in the form of you might also like type of recommendation engine based on customer similar purchase patterns in terms of the product categories and subcategories that they have purchased from. So AdventureWorks has all these tables that they use to store all their sales data. And actually, this also kind of complements the answer that Justin had earlier about SQL. So if AdventureWorks wanted to rely on SQL-based system to build this recommendation engine, they would have to perform, they have to derive the shopping context by doing multiple different pre-computed tables and then compare them against for each customer and then compare them customer by customer. And additionally, you also have to do this for each of the countries when you are trying to build this recommendation, which is going to be complicated because the country column is not in the customer or order tables. So now if you are going to try to use a SQL-based approach and have all these pre-computed tables and perform these customer-to-customer product comparison, you're going to have to abstract away a lot of the abstract away a lot of the comparison by using all these matrices and pre-computed tables that are going to be brittle when you constantly try to update the information. So then you're going to have this issue of not having the latest data. You're going to have your average business users who are not going to be able to understand how all these comparisons work in these kinds of pairwise comparison territories. But if you use Fabric Graph to transform this data into a graph model where all the sales data is represented using different nodes and edges, now you can very easily trace how different kinds of recommendations are based on the relationships between all these different data points. And these relationships are very straightforward and easily understandable by your typical business users. You don't need someone who's the data scientist or an AI engineer to be able to trace the traversals that your AI system has performed as it pulls out, extracts the data, identifies which customers have been making which purchases in which countries, and how the recommendation engine is using all this data to look at to surface recommendations. And compared to a SQL query statements, I would say it's a lot easier to be able to get for the non-technical users to be able to understand, to decipher graph traversals. As you look at these graph query statements, you can see that it's really just showing how the customer placed orders and how those orders contain different products. So when you have an AI system that leverages graph as the data grounding, as the grounding data source, you are going to be able to empower your non-technical business users to just trace the reasoning path that had powered your AI systems. And this translates to many different industries like finance, medicine, and many other sensitive industries where it really matters to be able to validate the reasoning, trace the reasoning path, to validate the analysis behind the conclusion that has been surfaced by your large language models or any other kind of AI implementation. Does that answer your question?
I think, again, like one aspect of the question was that how, in addition to improve accuracy, how can it remain explainable, and even more importantly, like ethically transparent? I think that we do have some controls. When you build a data agent, you do have some controls to make sure that the answers based on the graph data will be crafted in the way that you want them to be. So you can have some AI instructions and GQL samples. So you can nudge the kind of the model to use the data in the way that you like it to use. So for example, if you know that your data is modeled in a way that might lead to a connection to a data point that you want maybe to abstract a little bit, you can make this instruction, and then again, it will work. It's the same way that we are using today as consumers. All of the LLM kind of type of products, and we are trying to provide some more kind of clear instructions using the prompt. So that's the same type of mechanism. So that's the way that we're trying to both get the power of graph with the connections, etc., and also have some control over the responses and making sure that it is crafted in the way that it should supposed to be. Regarding security, we are also, again, as we are part of Fabric and consume the data from OneLake, we are respecting the security controls of OneLake. So in case a user is not permitted to see a specific set of data, or etc., the response will not bring it back to this user. So hopefully those aspects. What we'll cover, then the other two are somewhat covering what you asked. It's a good question.
Yeah. That makes sense. And Puneet, hopefully that was helpful to you as well. So one question we have from Zintu Fio. Hopefully I'm pronouncing it right. If not, I'm sorry. But Iggy, you talked about this Microsoft Graph versus Microsoft Fabric. Like, what are the differences? And I know you said it's not very related, right? Other than the name. But can you just touch on the scenario on how you can access, say, Microsoft 365 data?
Yes. Yeah, it's a good question. I think it's on the Fabric IQ level question, and we can touch it. So I think that again, if you have seen like the announcement of Microsoft at Ignite, and it will be reinforced now in FabCon, etc. Microsoft has these 3 IQs, right? Work IQ, Fabric IQ, and Foundry IQ. So and those IQs are kind of the idea of bringing the different contexts to those agents. So eventually, the agent revolution will be context based. Okay, that's exactly the same messages that we're also trying to convey in our kind of session here, right? That the context is the king or the queen. So so in this case, like Fabric Graph, only Fabric Graph is built on things that are in OneLake, right? Not in Microsoft Graph. However, when you build the semantic layer, right, this is the place that you need to connect, which is Fabric Ontology, right, part of Fabric IQ. You can connect it, or it's working together with the other IQs part of Microsoft, and specifically Work IQ, okay, which holds this Microsoft 365 data and graph, and that's the place where you kind of making sure that the ontology and the semantic layer that you are building is taking into account also this part of your data organization data, right? Why it is important? Again, it's important because let's assume you're running an operational kind of type of environment or a company, I don't know, like airport or stadium venues, etc. You would like to make sure that all of the information, and you are Microsoft shop, right? You're using Outlook, you're using Teams, etc. etc. You want to make sure that everything that you know exactly who works on what, in case there is an issue with some of the components during this kind of chain. You understand exactly. You can get the information from emails that are relevant, and then you can understand who exactly you need to target in order to message, to provide heads up, to solve it. Exactly. So it kind of combines the data, the productivity data that your organization kind of emits with your operational data, and everything together provides the best context.
Great. If you can let us know that if that was helpful, Zintufio, that'll be great. One other question we have from Sarah Seyoseke is, for organizations that have mature BI environments, and we see this every day, right? People are used to working with Power BI or other BI tools. What are some practical ways to get started with Graph? Justin, I don't know if you want to take this one.
Sure. Yeah, this is a great question. So it's something that goes hand in hand, especially when we start talking about displaying results and visualizations and things like that, is how do I connect this to a BI environment or a BI heavy environment, right? And in my mind, it goes very well with one of our offerings called Ontology. So the way that Fabric Graph plays in the Fabric ecosystem, the way that we have these connections to different tools that live inside Fabric is going to become more and more mature as we go along. Now, from the BI environment side, going into Graph, luckily, usually the data is in very good shape. So it's usually your gold level data, right? The one that you want to display to other people that are consuming it. So that's a good start. But B, it's going to sit in Fabric, hopefully. Hopefully it's sitting there already. And if so, very easy to get started. So as long as the data is sitting in OneLake, Parquet, CSV, we can go ahead and start engaging with building models And luckily, we can start very easily. Right? So I can do a, build a node, build another node, build a relationship, see if the data is coming out the way that I think it's going to, and then go from there. And the complexity of the model can evolve with the questions that you'd like to ask from it. We do have an open communication as well. Sarah, I think it's a cool name. Sarah says okay. I think is that it's like I don't know.
Anyway. I thought it was the last name and I was trying to pronounce it, but that makes more sense.
Yeah, it made me giggle. I think that yeah, it's funny. Thanks, thank you. But yeah, I think one of the things as well is you have people here on the phone that would jump on a call and we can walk through what a model looks like, what your questions that you'd like to ask of the data are, and we're here to help. So that's getting started in your graph journey is one of my favorite parts of this whole thing is the modeling and getting ready with the data because it's so exciting.
Yeah. One of the things I would love to say, Sarah, is, get started, join us on the community, right? We have a very active Fabric community forum. Come there, share your experience. Will, Justin, Iggy, all of us are always monitoring that community forum. So we'd love to take your questions there, help other people out in the process as well. And you'll just see the link in the chat on how to join the community. So next, let's take a question on handling temporal edges. We're getting a little more deeper into this graph scenario here. Nader, how about you take the, sorry, Justin, how about you take this question from Nader about how do you handle temporal edges in a hospital graph schema? So if the same patient is visiting the same doctor 5 times over 6 months, how are you adding that time series context?
Yes, I love, these are some great questions. I love it. Yeah, so this is one of the more common questions of how do I bring in something where it might feel repetitive to bring in the data into the graph itself. There's many different ways you can use this data in a graph. And I will go back to what I kind of said earlier. It's depending on the question you want to answer from that data. Right. So there's a couple different ways. One is we could add an edge for each individual visit. Right. So that's a fairly common way to do this. And if you have a very large graph, it might make the graph grow slightly. I see 5 times over 6 months. I'm not too concerned about that. That seems like a very consumable amount of data. And since we are a very horizontally scaling solution, which Iggy mentioned in the early presentation, 260 billion elements in LinkedIn, I'm not super worried about that. I probably have hundreds of millions of patients, a few hospitals, hundreds of doctors, things like that. So that scale is kind of small and very handleable. Additionally, you can create a visit node and just have the node itself as a visit. You can have all of the temporal data as a property on there, and you can have that data just kind of evolve in your graph model itself, right? For instance, if I go from one appointment to another appointment, that other appointment might be with a specialist, right? So I might be able to add on additional information to that second visit with a specialty doctor, things along those lines, right? So as your model kind of starts to evolve, it really does depend on those questions you'd like to answer. But hopefully, Nader, that gives you 2 different solutions for that problem. I've seen both work very well. But there are some things to watch out. One thing I will add on to that before I get down a rabbit hole here. But one thing I will mention is that when we add on temporal data, when we start adding in a time aspect to this, let's be very clear and very careful on not to add in any telemetry data as an identifier for adding in data, right? Because that becomes extremely complicated and that will blow your graph up as far as edges are concerned, right? So if I have a millisecond changes, that means all of my systems have to be in perfect symphony in order to get the right answer in, or I'm gonna write maybe several times and it might be off a millisecond, and then we have to go back and reconcile all of that, and it becomes kind of a little bit of a mess there. But if we do the cleaning beforehand, then we should be good.
Yeah, awesome. So I guess my takeaway from this is don't treat graph as just like a point solution for a point in time problem. It handles temporal situations as well. Great, over time. That's amazing. So we have one question from Pablo that says, where can we find information about the cost of maintaining up-to-date graphs? Maybe they've heard from some Microsoft colleagues that common AI agent use cases might be expensive. Hopefully, we can debunk that for you, Pablo. But Will, how about you take this question on costs?
So the pricing for Fabric Graph is also listed on the overview documentation, for which a link is shared at the very beginning of this session. As for the question for common AI agent usages, I think one thing we would need to define is what we mean by common AI agent usages. If we're talking about everyday individualized use cases where pretty much all the data sources like your documents, emails, and such can fit into the context window of your agent, then yeah, sure. You don't even need vector-based retrieval augmented generation or anything sophisticated other than simply dumping everything into the context window. But now if you're looking at enterprise-sized data sets where you have to query, search, and join hundreds of tables across dozens of different databases to try to pinpoint a lot of needles in the haystack, it's going to be really expensive to put all that data into your context windows. And if you solely rely on vector search, then you're going to have this issue mentioned at the beginning of the session where you're going to struggle with identifying relationships unless you perform very recursive joins or multiple different joins, which are going to turn out to be resource intensive as well. And in these situations, it might very well make more sense to actually spin up more CPUs to power a graph that enable your relationship-based retrievals to pull all those needles in the haystack without spending too much money on your LLM tokens.
Awesome. Hopefully that makes sense. Let us know if you have any follow-up questions on that. One of the questions I wanted to touch on, and Will, this was based on your presentation where you were sort of showing that graph query language, the GQL traversals and things like that. And Iggy, you touched on how GQL is the ISO standard, right? How does somebody get started or learn this new query language? Maybe they're not familiar with it. They're coming from the T-SQL world or Spark world maybe. So what is the query language behind Graph? How is it different from Cypher? Maybe Justin, if you can touch on this one.
I would love to. Yes, so that's a good question as well. So GQL is the ISO standard as indicated, right? So it's not standardized on any vendor-based solution, right? So Cypher is specific to a couple different solutions now. There's OpenCypher, right, which is for consumption externally, but the standard is pretty much run by one individual vendor. So what has happened is everybody came together and said we should do this standard GQL. It's declarative. It's very similar to Cypher because it's just the way that you model a node and an edge and the way that you match a node and an edge, just very similar. And if anybody is been around long enough to remember ASCII, the art they used to make with the parentheses and all that, so you can make the stick figures. It's kind of similar to that, right? So I have a parenthesis that incorporates some sort of node entity, and then a line and brackets, and another line to do the edge. And it might take a little bit of time to get used to as far as just the syntax is concerned. But it's a very big as far as in the community and questions. Nandini mentioned that we do have a community page. We have links to GQL documentation. And in general, as always, you can reach out to us and ask any specific questions about implementation or optimization. And we're going to continue to build the documentation and as we go along as well.
Awesome.
And just to add on that, as we saw, right, we also have this data agent, right, which you can ask natural language queries, and then it translates into GQL, and you can, in the data agent, you can actually see how the GQL was formed, right? So you can start learning there, or in our low-code query builder, which you also saw in the demo, when you're just picking nodes and picking images, etc., and running the query, you can then go to the query builder, change it from query builder to the GQL query, and then you can see the actual GQL query that was resulted from this kind of no-code action. So you have really several tools that you can use in order to generate automatically GQL queries, and then you can understand, okay, now this is, by the way I kind of jumped into this because I didn't know what GQL is like a year ago. So it's pretty fun.
Yeah. One other tip I would say is, a lot of people get started by doing, some people love documentation, but the way I love to learn is by coming to conferences, meeting the product teams, sitting with other people in the same boat. We do have our Fabric Community Conference next week happening in Las Vegas. So one other question I saw from Zintu is, you're learning about new topics. What is Microsoft Fabric? What is Graph? How do they integrate? How do they work together? So for somebody who's just getting started, we'd love to have you at Fabric Community Conference that's happening next week. We'll have another one in Barcelona in Europe sometime in September. It's really a great way to get those live sessions, meet the product experts, get your questions answered. So we hope to see many of you there. The next question we'll take from Haryan Gosika is around data warehouse and BI and how that compares to graph. So in data warehouse and BI, we typically use relational models like facts, dimensions, joins. These are the terms they're familiar with. But how does graph modeling in Fabric add value for analytics or AI use cases? And if we can have an example. Iggy, do you want to take this one or?
Sorry. Yes. Again, like there, I think I think it was Justin that mentioned it all depends on the different tasks that we would like to do. Okay. I think that we have enough time here to touch all of the other aspects of modeling, etc. But again, like for graph itself, it's like there are very typical. If your data, if you have like a lot of data points, right, a lot of tables, and there are a lot of connections between them, so probably the best modeling would be through ontology and graph, right? Because that's exactly where it shines, right? If you need to do the same in tables and relational tables, and then on top of it some modeling, it will be probably a little bit less performant and less intuitive, right? So again, like I know it's probably a bit a high level kind of answer, but that's the kind of rule of thumb. Like if you have a lot of connections between your tables and the type of questions usually force you to traverse between the different tables and connect the dots, use these connections. So graph is probably the best modeling and the best engine that you can use.
Awesome. What about like when you think about data sources or different file formats? Maybe Anaka, you can take this one. But what sort of data sources and file formats are supported in graph modeling? Because somebody's coming from a different world, they might not know.
Sure. So Fabric Graph builds on OneLake back data. So it has first-class support for lakehouse tables, which are stored in the Delta Lake format. The data physically stored as Parquet is also surfaced through lakehouse tables. So while OneLake can store multiple file formats, graph modeling is done over structured tables, with Delta Lake being the preferred and optimized format across Fabric. Also, to add to it, I think Delta also provides transactional consistency, schema evolution, and performance optimization, and Graph relies on this.
That's great to know. One other question we have in the chat is from Nader on limitations of Microsoft Fabric compared to, say, Neo4j or Azure Cosmos DB with Gremlin API. So it's hard to answer this type of question in a forum like this. What I would encourage you to do is really evaluate for your own use case versus do a generic comparison of different products. And if you have a Microsoft account team, please work with them. They can help you work through architectures or use cases for your scenario. We also obviously have the Fabric Community Forum, where as you're getting started and you're maybe used to a different product and you have a question on Graph and Fabric, please use that forum to ask us some questions. So we typically like to refrain away from just apples to oranges comparison. So it doesn't really make much sense in that context. Um, but we'll keep it going. We have another question from Seaboyda. So Fabric IQ ontology is the step after tables/data is already cleaned and golden. I'm not sure if that's a question, but I think they just sort of want to validate, right, where ontology comes in. So, Iki, I think you touched on this. Maybe you can answer this one.
Yes. So I think again, like like a lot of answers. I'm sorry, it depends, right? But really, like, but generally, yes, right. When you're at a point where you're creating an ontology, usually it's the highest or one of the highest kind of semantic layers that you need some abstractions for, and that's like it is sometimes treated as golden. However, in Fabric you have different other items and capabilities to deal with all types of data. If you are familiar with the RTI, real-time intelligence, workload with a lot of items there. Everything is like very much pointed in dealing with all levels of data, including the most real-time ones that are completely unstructured, etc. And everything works together. So the short answer is for Fabric IQ, yes, but in general, Fabric has your back across the board, like for all different of use cases, all different type of maturity of data, so on and so forth. And again, like it's pretty hard to elaborate now, but we will share some links, and of course the next FabCon is also going to talk about the Medallion format and architecture. So stay tuned.
And I also would like to add a point that it depends on what you mean by your data is already golden. What Fabric Graph allows is also some degrees of transformation that can further expand the kind of scope the kind of insight you can get from your data. So from an example I showed earlier, where you have this company called VentureWorks, using all these different tables to store their sales data. The column country is a column within the salespeople table, and with Fabric Graph, you can kind of transform your data so that you can now create this country entity from that column in your salespeople table. And now you're going to be able to perform a whole new slew of different kinds of analysis that would have been much more complicated or even nearly impossible when you just solely rely on the original tabular data format.
That's great. Hopefully that answered your question. Let us know if you have any other follow-ups. And one funny comment from Elpa Puyasi is, so the answer is homework, and the answer is always yes, right? Like homework is our community, our documentation, coming to Fabric Community Conference, or just, being tuned into events like this on YouTube. It really helps you get smarter about these concepts. So one of the questions that we had coming in from different forums is on GQL, right? So maybe a question to you, Will. What GQL features are supported in Fabric Graph today?
It's going to be a long list. Maybe the answer is going to be homework again, as one of our documentations that's publicly available does list the currently supported GQL syntax versus those we're still developing. It's the document is titled Limitations for Fabric Graph.
That's great to know. So I know we're at time. I'm going to hand it back to you, Anna, but we will look out for some of the questions, take follow-ups on anything that we weren't able to answer today. Thank you so much.
Thank you very much.
Thank you all for joining, and thanks again to our speakers. This session is part of a series. To register for future shows and watch past episodes on demand, you can follow the link on the screen or in the chat. We're always looking to improve our sessions and your experience. If you have any feedback for us, we would love to hear what you have to say. You can find that link on the screen or in the chat. And we'll see you at the next one.